Hi, my name is Shafaq Azari. My title project is signal detection for gear fault using data acquisition. So introduction is gear is one of the important machineries of our mechanical system. As it can transfer the power with accuracy, it will be predominating as effective means. Gear failure can occur due to insufficient lubrication, excessive applied load, installation problem, or manufacturing errors. Objective for my project is to characteristic behavior of gear signal, development of integrated analytical method, and validation of integrated analytical method. So for scope is to compare the difference between vibration signal and sound signal in gear fault detection using data acquisition, which is contain some simulation using MATLAB. So for second is to identify which signal is normal and abnormal for gear. So we will use healthy gear and faulty gear. And then new solution is by using sound signal are usually obtained by microphones, which consider contactless sensor compared to vibration signal that use some sensor like displacement sensor and velocity sensor. For literature review, I put some operation of gear, which is when one huge gear is connected to small one, the big gear can be turned slowly while the small gear rotates swiftly. One gear can accelerate the rotation of another, but it can also cause it rotate in the other way. So a gear train is when two or more gears are linked together. The gear turning is known as the driver, and the gear trying to move is known as the driven. Most commonly used type of gear is spur gear, helical gear, bevel gear, and worm gear. So this is literature review. I put 4 different journal, which is first journal is the effect of the operating condition and two fault and gear vibration signal. The objective is the effect of the operating condition on the vibration signature. Second, the behavior of two fault in the vibration signature. And third is improving the detection capability based on the understanding of the physical phenomena. The method is a realistic non-linear dynamic model is used to predict the vibration regime of spur gear transmission. So for the result, the RMS and kurtosis level of the damage condition are higher for the heavier load. So the model allows to simulate each combination of rotational speed, load, and surface roughness, and to isolate its influence on the dynamic response. So for the first journal, author with year is at 2021. For second title, second journal is a fault feature analysis of crack gear, considering the effect of the extended tooth contact. The objective is to diagnose the gear fault, develop a finite element model of a gear rotor system with tooth crack. So the method is considering the effect of the extended tooth contact and tooth root crack on the time varying mesh stiffness (TVMS). A finite element FE model of a spool gear pair in mesh is established by ANSYS software. So for the result show that considering the effect of extended tooth contact (TVMS) of cracked gear pair becomes smooth from double tooth engagement to single tooth engagement. So this journal is at 2017. So for third journal is gear fault model and dynamic based modeling for gear fault detection. So the objective is gear fault detection procedure using vibration signal analysis and presenting different gear failure modes and their models. For method is the method applied for gear tooth fault detection using vibration analysis with an emphasis on tooth fault modeling and dynamic simulation. So for the result is the finite element method (FEM) has been applied for calculating gear mesh stiffness, and it's easier to extract the time varying mesh stiffness (TVMS) using the analytical approach, and this approach has produced results which in many cases have shown good agreement with those obtained with the FEM. So the FEM requires the modeling and simulation of the problem for each specific tooth fault size. So the analytical approach requires less computation time than FEM. The last journal is impact of gear tooth surface quality on detection on local fault. The objective is to using a dynamic models and for simulation of gear vibration, a modified analytical expression for describing the tooth surface. The method is a dynamic model was used to simulate the vibration of gear with different type and size of fault. The result it was shown that gear with high quality tooth surface allow detection of smaller fault as well as classification of the fault size. Meshing of different surface gear teeth of the same precision grade can generate distributed results. So next slide is about data acquisition. So the dynamic reaction is measured experimentally using data-driven approach or theoretically model using modeling-based method. Many of these issues can be solved by modeling and simulation, which can also be a useful alternative for quickly analyzing the dynamic behavior of the gas system in question. However, the simulation approach requires input data such as the system dynamic properties, excitation, and degrading properties of the system component with time, rotation, and load. Okay, for signal analysis, a signal is a series numbers derived from measurements that are usually obtained using the recording method as a function of time. So we usually play with time domain and frequency domain for analysis. Time domain, like analysis of the time based analysis of physical signal, mathematical functions, or time series of economic or environmental. An oscilloscope is a common tool for viewing real-world signal in the time domain. So for frequency domain, is a method of analyzing signal or mathematical function in terms of frequency rather than time. A frequency domain graph shows how much of the signal is contained inside a certain frequency band throughout a range of frequencies. Next slide is difference between time domain and frequency domain in graph. So for methodology, equipment setup needed is first drive unit, second is magnetic clamp, third is elastic coupling, four is speed sensor, five accelerometer, next gearbox and accelerometer too if needed. So for general setup, speed need to set at 1200 rpm. Number of teeth on small wheel is 25 and number of teeth on large wheel is 75. So engagement frequency is a number of teeth multiplied by running speed. So for normal gear running, first check that all parts are fit securely. Then close the protective hood. So switch on the control unit for the motor and set the desired direction of rotation. Then we set the speed to 0 and switch on the motor. Then set the speed to 1200 to 1500 rpm and switch off the brake and load unit control or set the load to 0. So the last is record the frequency spectrum using the PT500 04 software. First select the velocity parameter for the y-axis in the mode drop-down list. So for the testing defect gear, just repeat the same procedure as normal gear. So for simulation is running by MATLAB. MATLAB is used to evaluate and build system and product. So by build some coding for running this project, MATLAB will process the signal for normal and abnormal gear.